Hi friends, welcome to the Unit 3 Day 2 video. This one talks about the factor theorem. When you have p of c equals 0, then we know that x minus c is a factor of whatever that polynomial is. Similarly, if x minus c is a factor of p of x, then we know that p of c equals 0. Those go both ways. It's called a biconditional. You learned that back in geometry. So what we're going to do is we're going to use the factor theorem and basically say, like, all right, is x minus 2 and x plus 1, are they factors of this polynomial? So let's see. So here, I'm going to use synthetic division. And again, whenever we use synthetic division, it's what makes this value 0. So I'm going to use synthetic division here. I'm going to check 2. So is 2 going to be, or sorry, x minus 2, is it a factor of this? So again, if we get a remainder of 0, then I know that it is indeed a factor of this polynomial. Bring down the 1. 1 times 2 is 2. 1 plus 2 is 3. Times 2 is 6. Negative 4. Negative 8. Negative 12, negative 24, and I do in fact get a 0. So because I have a remainder of 0, that tells me that x minus 2 is a factor. Now, if I went through and got a value that was a different remainder, so a remainder of any other number, except 0, then I know that's not a factor. So if I did x plus 1, so again, now I'm going to check negative 1, and I'm going to go ahead and redo this problem, again, pulling from the same coefficients from earlier. I wouldn't necessarily have to in this instance. I could have used this value instead. And the reason why is because this value is just this x minus 2 factored out. It shouldn't make a difference as long as it is a factor, again, remainder of 0, that I could check it. However, if you're ever in doubt, just go back to the original. 1 times negative 1 is negative 1, 0, 0, negative 10, positive 10. Negative 6 is 6, and that gives me a remainder of 30. So because that number is not 0, then I know x plus 1 is not a factor. Is not a factor. So again, you have to have a remainder of 0 to get a factor. If I know that a 0, the zeros exist, and they are these values, then I can build the polynomial. So now I'm going backwards. I'm given the zeros, the things that if I did synthetic substitution or synthetic division or long division, I would end up with a remainder of 0. I'm going to go backwards and build the polynomial. So if it has a 0 of 3, that means that whatever number I plug into this x here has to make this equal 0. So how can I make 3 equal 0? A good way of doing that is just setting that equal to 0 and then solving. So if I think about this, I have to minus 3 from both sides. So that tells me that I need to subtract that negative. I need to subtract 3 from the value of x to find my result or my answer. Same with plus and minus square, or sorry, same with the plus square root of 2 and then the minus square root of 2. So I would subtract square root of 2 to get this value to be 0 for this one, and I would add square root of 2 to get this value to be 0. Now when I go through and multiply these, there is an easier way to do it. You want to multiply these two first. And the reason why you want to do that is because that is a difference of squares. And realizing that is going to save you a lot of time. So I'm just going to bring down the x minus 3. Knowing that this is a difference of squares, I'm going to use some of the factoring techniques that we discussed earlier. X times x is x squared. And then these terms, again, are going to cancel. Minus square root of 2x, and then plus square root of 2x. Remember, those cancel. And then I have minus square root of 4. If I simplify all of this, I get x minus 3 times the quantity, x squared, and then minus 2. Remember, those cancel. So now I need to multiply these two pieces together. You can use whatever method you wish. Soon I'm going to show you the table method, if you've not seen that before. This particular problem, it's taking these values here, and those go in your first column. So I have x, then negative 3. I'm multiplying, so I'm just putting a multiplication symbol there. And then for my first row going across, I have x squared and then negative 2. X squared times x is x cubed. X times negative 2 is negative 2x. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 2 is a positive 6. Now I just list these out in order from greatest to least. X cubed minus, I missed an x squared there. There we go. Minus 3x squared minus 2x, and then plus 6. and that is the polynomial that's built from those zeros. Notice that we had 3 zeros, 1, 2, 3, and we had a degree of 3. That is important. That has to exist. Whatever your zeros are, that's the highest degree or power of the polynomial. For example 7, given that 2 is a 0, use the factor theorem to help find the other zeros. So in this instance, I've given you one of the zeros. You're going to have to find the rest. Now, this may look a little bit daunting, given that it's a 4th degree, but after we get it down to a cubic, then maybe it'll come out with a factoring technique that we know. Let's find out. 2 is a 0. I'm going to use synthetic division to divide out that 2. So 1x to the 4th, 1x cubed, negative 10x squared minus 4x, and then 24. Bring down the 1. 1 times 2 is 2. 3. 3 times 2 is 6. Negative 4. Negative 8. Negative 12. Negative 24. So we know that that's the case. We knew that it was a 0. So we're going to find the other zeros. So what is this? Well, this is x cubed plus 3x squared minus 4x minus 12. How did I know immediately that was x cubed? I knew that it's 1 degree less than what we started with. We started with the 4th degree, so that I know that this has to be 1 degree less. Now, if I was asking you to go through and factor this, then you would look at it and say, factor by grouping. And that's how we're going to approach this, factor by grouping. So if I factor by grouping, again, I'm looking to see what I can pull out. The first 2 terms, which is an x squared, I'm left with an x plus 3. What can I pull out of the second 2 terms? Minus 4, and I'm left with an x plus 3. So again, I'm left with x squared. Oh, so sorry. Again, pull out using grouping, pull out the x plus 3, and then you're left with an x squared minus 4. I can factor x squared minus 4 because it's a difference of squares. So that's going to give me x plus 3, x minus 2, and x plus 2. A lot of students will miss this. I gave you a 0 in the very beginning. That's another one. 2 is a 0, so that means it was x minus 2. So now that I have this polynomial, p of x, we found our other zeros. This polynomial, if I was to rewrite it, I would rewrite it as x plus 3 quantities. Nope, x plus... hold on. Whoa, Nelly. X minus 2 quantity squared times x plus 3 times x plus 2. Fundamentally, it doesn't matter what order you're writing them in, because you're going to end up with the final result when you multiply them all out in standard form regardless. It did want to know what the other zeros are. So 2 is a 0. 2 is actually a 0 twice. We'll talk about multiplicity in the next section. So we have 2 is a 0. So the zeros are 2, negative 3, and negative 2. So those are the zeros for this polynomial. And the last part that we have is the application from the beginning. It says, what was the discharge rate in June? Going back to the very front of the packet, it talks about where M is the month. So if I plug in June, or I do synthetic division with 6, I will find out what my value is for the discharge rate. So again, in this case, I could do d of 6, or I could do synthetic division. Doesn't matter which path we go, because we know that we're going to end up with the same value. So it's going to be negative 6 to the 4th. Notice that that negative sign is outside of the parentheses. Plus 22, 6 cubed, minus 147, 6 squared, plus 317 times 6, plus 150. I don't know negative 6 to the 4th power off my head. I did at one point. So I'm going to grab my graphing calculator here and just do parentheses, negative 6 to the 4th. So that's going to be negative 1,296 plus 6 cubed is 216 times 22, so that's going to be 4,752. It's going to be a minus. So 6 squared, 36 times 147, so that's going to be minus 5,292 plus 317 times 6, 1,902 plus 150. You'll see me often forego putting commas in problems that I have very long addition or subtraction problems, and that's just to keep everything looking clean. Sometimes it looks like a stray mark, and it'll affect what you plug in. Negative 1,296 plus 4,752, 3,456. Minus 5292. And so this is 216. So remember, going back to the very beginning part we talked about, it's 216 thousands of cubic meters. Thousands of cubic meters of water per second. So the rate in June, the discharge rate, is 216 thousands of cubic meters of water per second. And then for part B, I am then now comparing the two, comparing February and October. February, I know February is the second month, October is the 10th month. So I'm going to compare them by plugging those values in. So I'm comparing D of 2 and D of 10 to see which value is greater. To not run over time in this particular video, I'm going to essentially use my calculator to find my result, and then compare them at the end. So plus 22 parentheses 2 cubed minus 147 2 squared plus 317 times 2 plus 150. So that's 356. So it's greater in February. And then I'm going to plug in 10. Oops, wrong spot. There we go. 10. There we go. And then 620. So comparing these two, you can see that the October fall rains, in October, there is more discharge than February. There we go. All right, thank you, friends. Hope you have a wonderful day, and I will see you later. Bye.